This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B General candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The fastest way to turn a clean framing job into an engineered repair is to let somebody treat an I-joist like a 2x10. A solid-sawn joist and an engineered joist may occupy the same bay, but they do not give the field the same permission to cut. That is the central rule I want you to carry from this lesson. For engineered floor and roof members, I do not authorize a cut, notch, or bored hole from memory. I verify the manufacturer's published detail, or I obtain a design from a registered design professional. That rule sounds strict because it is strict. Engineered members are not just ordinary boards made in a factory. Their shape, materials, glue lines, and grade are coordinated as a structural product. A field alteration can remove material from the exact place the product depends on. The practical consequence is simple. A route that saves a plumbing or duct transition today can create a framing rejection, an engineered repair, concealed damage, or replacement work tomorrow. I also want to separate two decisions that often get blended together. The first decision is whether a field opening is permitted at all. The second decision is whether its size and location are permitted for that exact product. A hole chart answers both only when it matches the manufacturer, series, depth, and installation condition on the job. A familiar-looking joist is not enough. The California Residential Code makes the solid-sawn and engineered distinction directly. For floor framing, Section R502.8.1 gives prescriptive limits for solid-sawn joists. A notch in solid-sawn lumber is limited in depth, limited in length, and kept out of the middle 1/3 of the span. The next section, R502.8.2, does not hand those same ratios to trusses, structural composite lumber, glued laminated members, cross-laminated timber, or I-joists. Those engineered members may be altered only when the manufacturer's recommendations permit it or when the alteration has been specifically considered in the design by a registered design professional. The roof framing rule follows the same basic separation in Section R802.7.2. Looking at this comparison, I want you to notice that the solid-sawn column contains prescriptive limits, while the engineered column sends you back to product-specific or design-specific authority. That is the memory connection. Solid-sawn may give you a prescriptive code limit to verify. Engineered sends you to a product file or an approved design. Suppose a carpenter remembers that a solid-sawn notch may be no deeper than 1/6 of the member depth and no longer than 1/3 of the member depth. That memory can be useful on the correct member in the correct location under the applicable code and plans. It becomes dangerous when it is carried over to an I-joist flange or a laminated veneer lumber beam. The ratio does not travel with the worker. The member type controls the rule. This is a testable concept based on the published CSLB study guide because it sits inside subfloor, wall, and roof framing supervision. The practical skill is not reciting every product table from memory. The practical skill is recognizing when a prescriptive answer is unavailable and knowing whose instructions control. An I-joist makes the reason easier to understand. It has a top flange and a bottom flange connected by a thin vertical web. The flanges may be solid-sawn lumber or laminated veneer lumber. The web is commonly oriented strand board or plywood. Adhesive bonds the parts into one manufactured member. Under a typical downward floor load, the joist bends. The top region is mainly in compression and the bottom region is mainly in tension. The flanges sit at those outer edges, so they do most of the work resisting bending. The web keeps the flanges working together and carries shear through the member. In this table, the top flange, web, bottom flange, and bearing zone have different structural jobs, so they do not receive one universal cutting rule. The flange rule is the cleanest one to remember. Do not cut or notch the top flange. Do not cut or notch the bottom flange. A saw kerf, a plumber's notch, or an oversized drill that touches a flange is not a small web opening. It is a flange alteration, and I stop the work. The web is different, but different does not mean unrestricted. Manufacturers commonly permit certain web holes because the web can be opened within tested and calculated limits. The controlling limits include hole size, shape, spacing from other holes, distance from bearing, joist depth, span, and product series. I do not turn that list into a homemade formula. I use the exact published chart or an approved design. The load path explains why location matters. Near a bearing wall, beam, or hanger, shear demand is commonly high. Farther toward midspan, a manufacturer may permit a larger web opening because the force pattern is different. That does not make the middle of every joist an automatic drilling zone. It means the manufacturer's table may change the permitted opening as the distance from support changes. A useful field sentence is this: flange means stop, web means check. It is short enough to say during rough-in, and it keeps the crew from confusing an allowed web opening with permission to touch the flange. I want to put that sentence into a realistic coordination decision. Imagine a plumbing crew needs to route a large drain through an engineered floor. The shortest path places the opening close to a hanger. The crew has a hole saw ready, but the current manufacturer chart is not on site. The correct supervision move is not to guess from another brand, not to scale a photograph from the internet, and not to say that the hole looks centered in the web. I stop the cut and verify the exact product detail. Once I have the correct chart, I check the joist identification, depth, series, hole diameter, shape, distance from the support, and spacing from nearby openings. If the proposed route falls outside the published limit, I coordinate a different route or obtain a registered design professional's detail. That may mean a soffit, a chase, a shifted fixture connection, a revised duct shape, or a designed repair. The specific solution depends on the project. The non-negotiable part is that convenience does not become structural permission. The same discipline applies after a defect is found. An unauthorized opening is not repaired by instinct. I do not assume that a plywood scab, a short sister, blocking, screws, or a metal strap restores the original capacity. Some manufacturers publish repair details for specific damage. Other conditions require an engineered design. I preserve the product information, photograph the damage, stop concealment in that area, and obtain the controlling repair direction. This response protects more than the member. It protects inspection, readiness, and sequence. If drywall, insulation, mechanical equipment, or finish work hides the altered joist before the issue is resolved, access gets worse, evidence gets harder to read, and rework spreads into other trades. A 5-minute framing walk before concealment can prevent days of demolition later. Laminated veneer lumber, structural glued, laminated timber, and rim board belong in the same conversation, but I do not treat them as interchangeable. Laminated veneer lumber is made from thin wood veneers bonded with the grain running mainly along the length of the member. It is commonly used for beams, headers, and I-Joist flanges. When it is acting as a spanning engineered beam or header, I follow the manufacturer's technical information and the approved design for any alteration. I do not import the Solid-Sawn joist notch rule. Structural glued laminated timber, usually called Glulam, is made from larger wood laminations bonded together. A Glulam may look substantial enough to tolerate almost anything, but appearance is not permission. Drilling or notching can create a stress concentration, interrupt fibers and glue lines, and reduce capacity in a critical zone. The field decision stays the same. I verify a published allowance or obtain design approval before cutting. Engineered rim board runs around the perimeter of an engineered floor system. It matches the depth of the joists, closes the joist bays, supports the joist ends against rotation, and helps transfer perimeter wall loads through the floor system. Because it is part of that load path, and it is not scrap filler, openings and connections must follow the applicable product information, plans, and details. Product identification is part of supervision. I look for the manufacturer's name, product designation, plant or production information, and the mark of the qualified inspection or evaluation agency required for that product. I also match the material on site to the plans and submittals. If the stamp is missing, obscured, or inconsistent with the paperwork, I verify the product before it disappears behind finishes. That is one reason I keep labels, delivery paperwork, evaluation information, and whole charts together. The mark on the member tells me what I'm looking at. The technical document tells me what I may do with it. One without the other leaves a gap. This sequence table shows the field routine I use to keep the framing protected, while plumbing, electrical, and mechanical rough-in moves forward. I start by identifying the installed product and collecting the current manufacturer details. I give the relevant hole information to the trades before layout. I coordinate routes before a saw or hole cutter reaches the framing. I inspect the work before concealment. If I find an unapproved alteration, I stop work in that area and obtain the manufacturer or registered design professional's repair direction. Then I document the resolution and coordinate any required reinspection. I do not need a long meeting to make that work. A direct conversation at the start of rough-in can be enough. I point out the flanges, the bearing zones, the allowed web areas shown in the product chart, and the process for requesting a route change. Every trade has legitimate space needs. The general B supervision job is to resolve those needs before one system damages another. Consider a hypothetical project where an installer trims the top flange of several I-joists to gain clearance for a rectangular return duct. The cut may look small compared with the joist depth, but the comparison is wrong. The removed material came from the flange where bending stress is concentrated. I stop the installation, support the affected area as directed by qualified personnel, keep the damage exposed, and obtain an approved repair or replacement decision. I do not let a schedule meeting convert that defect into an acceptable shortcut. The same defensive approach applies to fasteners and hangers. A connector schedule, nail pattern, or rim board attachment is not something I casually substitute because another fastener is on the truck. Engineered systems are assemblies. The member, hanger, fastener, bearing, blocking, rim board, and sheathing work together. When one detail changes, I verify whether the approved system still works. This is where engineered wood connects to a broader construction principle. Continuity. Loads need a continuous path, water needs a continuous drainage path, and approvals need a continuous documentation path. A missing structural detail breaks that chain, just as surely as a missing flashing lap breaks a drainage chain. My job is to find the break while it is still visible and repairable. Structural compliance does not replace personnel safety during installation. Open floor framing creates a direct fall exposure before the subfloor closes the bays. California Title 8, Section 17, 16.2, Subdivision E. Paragraph 1 requires fall protection when employees are walking or working on top plates, joists, rafters, trusses, or beams 6 feet or more above the surrounding grade or the floor level below. The listed protection methods include scaffolding, guardrails, safety nets, and personal fall protection systems. I select and plan a compliant method that fits the task and site conditions. Experience, balance, a spotter, or a verbal warning does not replace one of the required protective systems. The 6-foot trigger matters during engineered floor installation because workers may be handling long members, placing sheathing, setting blocking, or moving across narrow top flanges before a stable deck exists. A small misstep can become a fall between the joists to the level below. The rule applies to the exposure, not to whether the worker has walked joists for years. I also coordinate safety with sequence, material staging, access, lifting methods, temporary bracing, and the order of sheathing can change how often a worker is exposed to open framing. I do not improvise a fall protection method from an audio lesson. I use the applicable California occupational safety and health requirements, the selected system's instructions, and site-specific planning. A tight job does both things at once. It protects the engineered member from unauthorized cuts, and it protects the worker from the open framing around that member. Passing a framing inspection is not a substitute for a safe installation, and a safe installation does not excuse a damaged load path. I want to leave you with a compact field check. First, identify the product. I-Joist, laminated veneer lumber, Glulam, rim board, truss, and Solid-Sawn lumber are not interchangeable labels. Second, identify the controlling authority. For an engineered alteration, that is the manufacturer's published recommendation, or a design that specifically considers the alteration. Third, protect the flange. On an I-Joist, no cut and no notch belongs in the top or bottom flange. Fourth, verify the web opening. Size, location, spacing, support distance, member depth, and product series all matter. Fifth, inspect before concealment. An exposed defect is a coordination problem. A hidden defect becomes a demolition problem. Sixth, protect the worker. At 6 feet or more on the listed framing surfaces, provide an allowed fall protection system. The memory line is simple. Solid-Sawn gives you limits. Engineered gives you instructions. Flange means stop. Web means check. When the information is missing, the cut waits. I made an audio practice quiz specifically for this episode on engineered lumber, I-Joists, laminated veneer lumber, manufacturer whole rules, and framing safety. It is audio-based. The questions are read aloud and you answer by tapping, which makes it useful when you're studying while driving, working, or moving through the day. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. I read those questions because they help me see where a field rule needs a cleaner explanation. Subscribe so I can help you stay on track through every episode until you get your license. I know this process asks a lot from somebody already carrying jobs, crews, and deadlines, and I am here to help you keep moving.